I don't know what's wrong with
Okay,
it.
I cleared the codes.
You're up.
I changed the oil, and now they haven't came back.
Yeah, they're probably going to have to make a couple of trips, you know, like it is on OBD2. Now this is emission system test 4. MAP barrel and mass airflow sensors. As the load increases on an engine, manifold vacuum decreases and the manifold absolute pressure does what?
Okay.
When I looked at the manifold absolute pressure reading on this Tahoe that we're working on out here, it read 14.5. Now what does that mean?
What?
I saw, you know, 14.5 as a reading on the scan tool for the manifold absolute pressure.
It's too high.
It was switched on, engine wasn't running, the manifold absolute pressure was at 14.5. So what does that tell you? What was the pressure equal to in the manifold without the engine running? Sea level, more or less. We're only about a couple hundred feet above sea level here. Got it? 14.5 psi at sea level. That's your manifold pressure when the engine's not running. When you crank it up, the pressure in the manifold drops. Okay? A typical MAP sensor, manifold absolute pressure sensor, compares the vacuum in the intake manifold to what?
D.
A perfect vacuum, believe it or not.
I don't believe it.
Okay, so which statement is false? A barometric pressure minus the MAP sensor reading equal intake vacuum. A decrease in manifold vacuum means an increase in manifold pressure. Absolute pressure is equal to barometric pressure plus intake manifold vacuum. And the MAP sensor compares manifold vacuum to a perfect vacuum. Which of those statements is false? Well, A and C cannot be both correct, so it would be A. And you know, what is a perfect vacuum? How is vacuum measured? You remember?
Inches in mercury.
Yeah, inches of mercury. What does that mean, Adam? I mean, where do they come up with that? How do they come up with inches of mercury? Somebody had to come up with that. Got a thing like this. Imagine something like this. Right? And imagine you've got this thing marked in graduations. 1-inch graduations. You know, who knows how many you got there. And imagine this is capped off. Right? All right. And here you've got mercury, and it's in a sort of a U-shaped tube, right? You got atmospheric pressure pushing down here, and you hadn't capped this off yet, so atmospheric pressure is pushing down here. Well, you cap that off, and you pump every last bit of the air out of this side while this side remains open. This goes up 30 inches. Now you know, right? That's why you cannot have more vacuum than 30 inches of mercury. That clear? Everybody got that? That's how that happens. That's how that was done. Okay? So, which design of a MAP sensor produces a frequency or digital output signal? That's going to be a tough question if you hadn't read the chapter. It's going to be a capacitor capsule frequency signal. You know the Bronco we got out here. Huh? Huh?
So I still gotta get my books.
Yeah, it's in the book.
No, I'm saying I still gotta get mine.
Oh. All right, we got this here 160 hertz approximately is equal to sea level on a sensor like the Bronco uses. Got 3 wires there. You got an orange wire, you got a green wire, and you got a black wire. Okay, the green wire, when the engine's not running, when you first switch it on, is your barometric pressure. MAP, mass airflow sensor, calculates that too. Well, a lot of these vehicles now, for a while, they stopped putting MAP sensors on them and they started just putting mass airflow sensors on them. That started in about 1985 on some cars. Now they had airflow sensors that had a vane that would move with a wiper on a potentiometer, kind of like a throttle position sensor. They call it a vane airflow sensor, and they had that before then. The GM came out with them, and they weren't going to do any kind of MAP and MAF until they discovered that they needed to know what the manifold absolute pressure was, so they started putting the MAP sensors back on it. Anyway, The 88 Ford that we worked on over here that the guy brought in, that old gray one with the camber shell on it I was talking about the other day, I went out there and it was really, really, really hard to start. Wouldn't hardly start, wouldn't stay running. I mean, it would start, but it was just basically die. And I went into that green wire without the key switched on, and I got something like, I got a picture of that somewhere, 89 hertz or something like that, which is totally stupid reading that didn't make any sense for sea level. And that was telling him he was at a really, 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 really high altitude. And so it wasn't going to put hardly any fuel in there. It was trying.
I changed up the fuel pump.
Huh?
I think I changed up the fuel pump.
Yeah, you did a fuel pump, but that was for another issue. But the fuel pump was dead too. But you put a fuel pump on it, and then it was still acting ugly. And so we put this. I went to the Bronco. I had somebody with me. I don't remember who was with me. And I measured the one on the Bronco, and on that particular day, and it's going to vary from day to day as pressure varies, it was like 158 hertz. And this one here was 89. Well, right away, you know, comparing a good one to the bad one is a good way to do that. I found that was bad, so I ordered a MAP sensor, mounted it up there, plugged the wires in, plugged the hose to it from the manifold. We're good to go. And that was not too terribly hard to do, but you had to know that. And sometimes it's hard to find in a book.
So when I go on my road trip, and am I got to worry about things with high altitude since I'm going to be going through Arizona and California? And
yeah, if you're driving a car that will probably look on your VECI decal and see what the altitude is that it's good up to. And like I say, it used to be 4,000 feet on most cars. Above that, you'd need some, but you can still drive it up there. You're just going to notice a reduced power, and it's not going to feel right and all that, you know. So yeah.
It's not going to destroy anything.
No, you ain't hurt nothing. You just have your foot into it pretty heavy all the time, trying to hold power to it. Frequency output of a digital MAP sensor reading is 114 hertz. What's the approximate engine vacuum? Now this sensor I was talking about, the one that, basically what it looks like is it's sort of looks like that, and it's got a wire connector, and it's got a vacuum hose on it that goes over to the manifold, and it usually is mounted in there sideways. It's that basically, when you crank it up, it drops from about 158 hertz down to usually about 110 is what I've seen, and it can be accurate at one end of that scale but not the other, so it's pretty dicey on that. But that's basically going to be B. That's going to be 15 inches of mercury. So it's a little higher than what's normal. What do you expect to see? What's healthy vacuum? What's a healthy engine got for vacuum? If it's idling, what's the vacuum should be on the hill?
20 or 30?
18 to 22 is what you're looking for. And you look on your vacuum gauge, you'll see a green range there for that. Which of these is not a purpose or function of the MAP sensor? Does not measure engine speed. There's no way it can. It does calculate fuel delivery, helps diagnose the EGR system, measures the load on the engine. How in the heck can you help diagnose the EGR system with a MAP sensor? Remember what I told you guys? If you hook your vacuum gauge up and you're watching your vacuum gauge and you open the EGR valve, what does the vacuum do? It goes down, right? So if you've got the MAP sensor and you're looking at the PID on your scan tool, and you can actually pick that as one of the PIDs you're going to monitor when you're doing a output cycle test. You can actually tell the mass airflow sensor, EGR valve to open and watch for the MAP to drop. You got all that right there in front of you, see? That's what it's talking about. And also, there's various different ways that these vehicles use feedback. Ford likes to use the DPFE sensor. General Motors used to look at the oxygen sensor. So if I operate the EGR, it's going to affect the oxygen sensor too, isn't it? Because you're putting inert gas in there. But the manifold absolute pressure sensor, I wasn't using on that. You okay?
Yeah.
All right then. All right then. Let's see. When measuring the output signal of a MAP sensor on a General Motors vehicle, the digital multimeter should be set to read what? They like to read DC volts on those. Basically, that's been around for a very long time. General Motors back in the early 80s, real early 80s, used to have a separate sensor for mass airflow, not for mass airflow, for MAP and for baro. And then they sort of rolled them together. Two technicians are discussing Testing MAP sensors. Technician A says a MAP sensor voltage on a General Motors vehicle at idle should be about 1 volt. Is he right about that? Actually, at idle, he is. Technician B says the MAP sensor frequency on a Ford vehicle at idle should be 105 to 108. And both those guys are right. Technician A says MAP sensors use a 5 volt reference voltage from the PCM. Technician B says the MAP sensor voltage will be higher at idle and high altitudes compared to when the engine is operating at sea level. That's C. Both those guys are right. 9 questions to go before anybody turns into a skeleton. We need to keep moving. Fuel injection system that does not use a sensor to measure the amount or mass of air energy in the engine is called what? In other words, you're not using a vane airflow, you're not using mass airflow. What kind of fuel system is that? That's a speed density system. There's also one called a density speed system. It's all about priorities, but speed density is the most, that's the one like on your, if you might notice that most Chryslers stayed away from mass airflow. They like MAP. You'll hardly ever see a Chrysler with mass airflow on it, right? Ford came out on 1989 on the Mustang with mass airflow. And they had mass airflow, but they didn't have any data stream. That would tick me off. What type of sensor uses a burn-off circuit? That's a hot wire mass airflow sensor. Now, you know how, you remember, hey.
What is a burn-off circuit?
Huh?
What is a burn-off circuit?
Basically, it cleans the mass airflow sensor whenever you turn on the car. If you look up in there, it gets blistering red hot. And that just cooks any dust or any material off of it. It's sort of like cleaning your oven, right? But Amber, you remember the other day when I was telling you how the mass airflow sensor worked when you and I were changing that one out?
In a way, yes.
Yeah, can you explain that now? So,
Probably not.
you don't remember any of it? What are we looking at here? 2 platinum wires. What we're going to do is we're going to do this, and we're going to put this little thing here, and we're going to put something here. Not a resistor per se, this is a little drum sort of a thing. And you got platinum wire wrapped around this. And it's going down into the electronics. You got one, and behind it, in other words, if you looked at these like this, they'd be like that, right? You got another one behind it. That one there is the hot wire. And it's made the same way. And so what it wants to do is it's measuring, it's using this one for its benchmark. It's keeping this one at 300 degrees Celsius. That's what I read in a, long years ago in some of the literature we had. And it is measuring how much current it has to send through this platinum wire to keep it at 300 degrees Celsius. In other words, it's using this for a comparison. It's keeping this one 300 degrees hotter than that one. And it can do it really, 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 really fast. And so as more air goes in, and, based on its comparison between that and that, it's measuring how much current it takes to keep that little platinum wire hot. Got that? That makes sense? Now, it takes the electronics in here and it changes that signal to either a frequency signal or a voltage signal or both. So basically, the voltage is going to be higher whenever it's taking more current to do this, or the frequency will be higher too, see? And they actually interpolate that now as grams per second or pounds per minute or whatever. So that's how those little hot wire sensors work. But those don't have a burn-off circuit. The GM ones, the earlier GM ones had a little thing. If you're watching it, when you turn it on, you see it turn red hot in there for a minute. That's the burn-off circuit. Let me see here. Which sensor has a switch that controls the electric fuel pump? That would be the vane airflow sensor, which has got a peculiar shaped box, and it's got an L-shaped flapper in it. And on the top side of this L-shaped flapper, up in here in the electronic part, there's a little thing, and whenever the thing moves, it slides. But as soon as it starts to move, when you're spinning it over and it moves that thing, it's actually going to close a little set of contacts that's going to operate your fuel pump. Now, on the older ones, they just let that run the fuel pump, and on the newer ones, they let that operate a relay, the ones that had that. And some vehicles that you may see in the shop will still have that, older Toyotas and stuff like that. Personally, I didn't like those sensors. You know why? Because when you needed one, they were $1,000 or something a lot of the time. Stupid money that they wanted for them. And I have seen an Asian-made vehicle with a mass airflow sensor on it that somebody had been fooling with it and managed to mess the little grid up in there that was supposed to study it. And that thing was $1,200 for a mass airflow sensor, and the car wouldn't run without it.
That's crazy.
And it was an Asian-made car, you know, but you can buy one from the parts house for one of these Ford or Chevrolet or something. It's only like $175. Now they want a core for it.
What car was it that cost $1,200?
That was a Ford Probe, but it was like a Mazda. You know what I'm saying? Yeah. Now that's not going to be the way it is always, because they went to the other kind right there later. But that one was in one of the earlier Ford Probes. Let's see. A typical mass airflow reading on a scan tool with an engine idle speed and normal operating temperature is
3 to 7.
3 to 7. Now the other day, who was I working with, you or somebody, and we had one that was consistently reading higher. Remember that? Who was I working with on that? What vehicle was that? It was, it was that, was it that Ford? What was it on? I can't remember what vehicle it was. That made me smack myself around. But anyway, it was consistently reading like 6 to 8 grams per second. Well, what would make it read a little too high like that?
It might have been Johnny, because I think he was talking about, he thought it was pounds, and you're like, no, it's not pounds, it's grams.
Yeah, grams per second. I don't remember, but the long and the short of it was, the reason it was doing that was because they had a bad thermostat and it was running too cold. If it was running too cold, the idle air control is going to be a little higher. If the idle air control is running a little higher, it's going to have more grams per second going in there. And when the engine's cold, you got fast idle, right? You're going to have more grams per second that way. So sometimes you can have too many grams per second because you're running at 168 degrees. That's not complicated, is it? If you think about it the right way. Something else you can do if you know how to do it is you can unplug your mass airflow sensor, and if you know which, you got to be careful with this, but if you know which wires power and ground it and which one's a signal, you can actually power and ground it and get a signal wire and measure it with your meter independently of the engine controller, and you can read what that mass airflow sensor is capable of producing. That's how that one on that board over there is hooked up. I got it hooked up so that it'll actually read, you know, there's air going through it because I got a fan pulling stuff through it. Let me see. 2 technicians are discussing a poorly running engine. There's no stored diagnostic trouble codes. Don't you love those? When the mass airflow sensor is unplugged, the engine runs better. Technician A says this means the mass airflow is supplying incorrect airflow information to the PCM. Technician B says this indicates the PCM is defective. Who's right about that?
A.
That would be A.
Skip 13.
I'm sorry, I didn't mean to do that. 2 technicians are discussing Karman vortex sensors. Technician A says they contain a burn-off circuit to keep them clean. Technician B says they contain a movable vane. Who's correct about that? Both those guys are not heads, and they're totally wrong.
What is a Karman?
Karman vortex has got, imagine this, and I've got one of those over somewhere. You've got a little, you got airflow, you got a sort of like a coarse honeycomb, you know, that if you looked into it, you'd be looking at it like a honeycomb. And the sensor has got on each side of it, if I'm thinking about the right one, sound waves. It's got a little tiny speaker and a little tiny listener, and it's a frequency you can't hear with your ear. And as more air goes through there, it has a tendency to blow those sound waves away from that other. That's interesting, isn't it?
Yes.
That is a very expensive sensor that you would see on Mitsubishis and stuff like that. And we've actually, somebody said one time that you could take a Mitsubishi or an Eagle Talon, which is made by Mitsubishi, or an Eagle Summit, and if you bought all of the fuel injection components, the injectors, the airflow sensors, the engine controller, and all that, brand new, it would cost more than buying a new car. Is that ridiculous or what? Okay. And that's the Karman vortex sensor. Okay, so let me see. Have you ever, I mean, but thinking about your sound, did you know wind can cause sound to,
Distort.
huh? Yeah, wind blows sound. You know, sound actually has got, and even in the Civil War, they would have these, somebody would be right on one side of a little hill, and they wouldn't hear a dadgum thing, but on the other side of the hill, there'd be a full-blown Civil War battle going, and they couldn't hear nothing. I mean, and it was like they were right there, but it was peculiarity of the way the sound was traveling over the hills and all that. It was called silent battle or whatever, but everybody who was in the battle could hear it, but the guy that was just right, you know, 500 yards away couldn't hear anything, cannons or nothing. That's a phenomenon. Let's see. The mass airflow sensor on a General Motors 3800 V6, which is like the car that you drive, is being tested for contamination. Technician says the sensor should show over 100 grams per second on a scan tool display when the accelerator is depressed to wide open throttle. Technician B says the output frequency should exceed 7,000 hertz when the accelerator pedal is depressed to wide open throttle on a running engine. What is it? This is a peculiar question to me. Is it to you? Does anybody else see a problem here? Technician A says the sensor should show over 100 grams per second. Oh, 7,000 hertz. Okay, never mind. Golly, yeah, both those guys are right. 7,000 hertz equals 100 grams per second. That's basically what they were saying there. Somehow or another, I misfired on that question and lost my train of thought. Which airflow sensor has a dampening chamber? That'd be the vane airflow sensor, the one I was talking about with a little L in it. And number 18, air that enters the engine without passing through the airflow sensor is called what? Well, I would not call it false air, but that's what these people would call it. Now,
is it real?
Yeah, that's peculiar. You know what I call it? I call it unmetered air. It's air that's not being measured. It's air that's making it into the engine, but the mass airflow sensor has not a clue it's going in there. And so what happens then? By the way, what are the ramifications of having unmetered air? What do you think it's going to do to the mixture? What's it going to do to the fuel trim?
Is it going to make it rich?
Well, and why? Well, you're on the right track, but why will it do that? Think about it.
Too much air is coming in.
Huh?
To compensate the amount of gas. And
Yeah, there's air in there that doesn't belong, or that's not being measured, and so it doesn't know about that air, and so it's basically just using what it knows is going in through the mass airflow. And how's that going to affect the oxygen sensor? It's going to be running too lean, right? And what's going to happen then?
so lean is when it has more air.
It's going to add more fuel to try to correct the lean condition, and that's going to force it rich, right? You understand what I'm saying? So you guys were sort of thinking in the right direction there. It's always important. Now here's something else. If you ever see a boot between a mass airflow sensor and the intake that has a little crack in it, sometimes you can't see them because that's got a convoluted boot. And somebody gives it the gas and the engine torques, and it opens up that crack. Then the engine will try to stall down some, and it closes the crack back up. And then it tries to open back up. And then you got a lot of unmetered air, and it goes back and forth. And so what happens when you go to take off, it goes, and just back and forth. I saw one with a mass airflow sensor partially unplugged, and it would torque, and it would plug and unplug it and do that. I kept expecting to find a crack in that boot. A P0102, these diagnostic trouble codes being discussed. Technician A says a sensor circuit shorted to ground may be the cause. Technician B says an open sensor voltage supply circuit could be the cause. Both of those guys are right. And
What's 11 and 12?
what? Where were you? All right. Did you leave the room then or something? Wait, anybody know? Number 10, a fuel injection system that does not use a sensor to measure the amount of air or mass in the engine is what?
B, speed density.
That's a B, speed density. And then the sensor that uses the burn-off circuit is the hot wire mass airflow sensor. You can kind of figure that out if you parse the words.
So what is a P0102?
Huh?
What is a P0102?
Oh, P0102 is related to the mass airflow. What it is. I mean, it's a mass airflow code, basically. What is the 102? I mean, what's the one on that thing over there?
On that thing over there, it means it's an OEM code.
No. P0102.
Oh yeah, the one
What?
means it's.
What is that? Do you remember?
I can't see it from here, unfortunately.
Yeah.
I think it says airflow something.
All right. This is where we're looking.
Air fuel.
There you go. Look at there. See, nothing complicated about that,
Well,
huh?
yeah, I figured that out, but I meant what exactly is a P0102? What is the O2?
Yeah, it basically means you got a, as I remember, it means you got a low, there's no mass airflow signal. And I will tell you something else too, a mass airflow sensor can keep one from starting. In some cases, doesn't usually happen, but I have gone out there and found vehicles on the lot that wouldn't start, and you go and plug the mass airflow sensor and they fire it up. And so,